this. All right, for today, May 11th. Forgot this. There we go. Just in case some of you guys forgot what day it is. The only reason I know is because my phone tells me every morning. All right, housekeeping. Today there's, on Wednesday, you guys have a test. I put a practice exam up on Friday, so I can give you guys all weekend to do it. Some of you guys have looked at it. That's okay. Some of you guys haven't looked at it. That's okay as well. Just make sure you get it done. And it is grade. It is a grade for you to do. And it'll go just like before. It'll go to your group quiz section. Us having an actual practice quiz or a practice exam. Okay. I think I left it open until Wednesday night, so you can technically take the test and then go back and on Wednesday try some more for your practice test. Okay. That's it. In terms of what I can tell you guys. Oh, I forgot to put that in. I'm trying to do this. There we go. Are there any questions from you guys in terms of stuff coming up, things that are still a little funky? I think I'm missing lecture question submission things for I think like chapter 5, 6, and 7. So I'll put those up later on today.
Did all the other ones.
Yeah, so I think some of you guys may not have been able to submit stuff.
They can't submit. Yeah, I can only submit up to 4.
Right. So that's my bad. I need to put those in.
Yeah, as soon as you do that, I can submit everything else.
Yeah. The practice exam, it is unlimited attempts. I didn't bar a number of attempts for this time. So keep going. Once you get the highest grade you think you want, you can keep that. Or you can keep trying and get it perfect. That's fine with me too. Any other questions from everybody? Any other questions from the crowd?
Yay. Is baseball going to start?
Really?
No, I said is.
Oh, I hope so. I wanted to get the A's All Access pass.
Yeah.
And like, so I had called the box office at the Coliseum to say, hey, what kind of deal can you give me, right? And I had started to talk to people, and they were selling me on it. A week later, nope, we got a lockdown. Ah, shit. Yeah.
I just think it's funny the states that opened up, now they're closing back up because people are stupid.
Yeah, the second wave.
Yeah, and then that guy died in Santa Cruz from a shark.
From a shark.
Yesterday.
Yeah, I saw that.
It reminds me of Olaf. Her parents are dead.
Oh my God. All right. No more questions. No more questions. I don't think so. Okay. For today, I want to finish up as much of 7 that we can. I think you guys had already sort of figured this out. Exam 2 is going to encompass chapter 6 and 7. So I want to finish up as much as, I want to finish up as much from 7 as possible. Depending on how close we get to finishing section 7.5, may or may not include that on the exam. Though I think I might just include it because it's not anything that you guys can't do. Let me put it that way. Yet. Yeah. Wednesday we have our test. Then next Monday, the Monday before our exam, there's 2 more sections we need to do. They're very quick, 8.1 and 8.2. That's it. We're done with the semester. So we're on the home stretch. You're on the home stretch. Okay. These. So actually, this is the only thing that was left, huh? Yeah. Okay. So just to remind everybody for what we've been doing for the last couple of days here. I've just been throwing a bunch of equations out at you, or identities, and they're all pretty simple to prove. I'm not going to concentrate on proving them for you guys. I'm actually going to concentrate on being able to have you guys use them, okay? So before, this one's actually pretty heavy. This section right here was actually pretty heavy. We had double angle formulas. We finished those just about. We have reduction formulas, and then we have half angle formulas. Next chapter, we'll see product to sum formulas. That's going to be real quick. And then we're going to start solving equations with them. Okay. So like I said, I'm not going to concentrate on where these equations came from. It's more about how to use them. Okay. These reduction formulas tend to be very, very useful in calculus. In particular, when you get to calculus 2, okay? So you guys don't know this yet, but you will know it once you get to Calc 2. I'm just gonna give you guys an example. There's this thing called an integral in Calc 2. And the integral is a calculus thing, a topic in calculus, where an integral you do sine squared of x dx. So there's this thing in calculus where called an integral, and you can take integrals of trig functions, okay? But you can't take them of squares. So this is lots of work, right? And part of the solution is getting it down to just getting the squares down to something simple like sine x, which is very simple to do. So the idea is it doesn't matter what that power is. It can be like 80, right? And what you do is you use these reduction formulas to bring it down to something simple, where you can do the integral. Okay? So this stuff that we're about to do is You probably may not see it ever again until you get to Calc 2, which is in about a year from now. Okay? So I'm going to grab cosine to the fourth of x and only turn it down to only a power of 1. So the exponent being 1. Okay? This is going to require a bunch of manipulation. Specifically, we're going to be using this one over and over and over again. Okay? So cosine 4x, that's the same thing as cosine squared times cosine squared. Right? Now I can use that nice little yellow one that I highlighted, right? So 1 plus cosine of 2x over 2. I should, yeah, I left it at x, okay. Divided by 2, okay? So now, I'm going to multiply these, right? The bottom is going to be 4. The top is going to be 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay? I still have this cosine squared 2x at the end. That's not power 1, right? So I need to bump that down a power. I'm going to use this thing one more time, okay? And in order to do that, I'm going to do 1 plus, I'm just rewriting the beginning part, 2x plus 1 plus cosine of 4x over 2. So notice this one is a single that got doubled in there, right? I got doubled in there. So I'm going to use the same rule, and that's how I got that thing right there. All divided by 4. I'm going to do some common denominator business here. On the top, I'm not going to mess with the bottom yet, okay? So it's going to be 2 over 2 plus 2 cosine of 2x over 2 plus 1 plus cosine of 4x over 2. So that's all on top divided by 4. See? Look what happened. So I forgot to carry around the 2. So just make sure you have your corrections on your own. Okay. After this, now I'm going to combine them all on the top. It's going to be 2 plus 4 cosine of 2x plus 1 plus cosine of 4x all over 2 on top, all divided by 4. Okay, and the 4 if you guys remember, make it to 4 over 1. Okay. If you do them, so you have here a division of fractions. You can flip the bottom one, right? Let me actually write it out. It's much easier to just write it out. So, 2 plus 4 cosine of 2x plus 1. I'm going to clean this up. That plus 1 and plus 4, I can make plus 3. It's a plus 2 plus 1. Make it plus 3 plus cosine of 4x all over 2, right? Divided by 4 over 1. We have a division of fractions, so what I can do, as always, is I can change it into a multiplication and do the flip of the second, right? So now you can multiply straight across. Okay, and that'll get us 3 plus 4 cosine of 2x plus cosine of 4x all over 8. Now we are done. We are donezos. Okay, this is the reason why reductions are so helpful. We grab something that's cosine of a power of 4. It doesn't look like it's much nicer, but when you're in calculus, you will very much appreciate being able to mess with this over this. Okay. So I've got 2 here. I want you guys to use your all of the trig identities that you know up to now. Okay. And I want you guys to prove these 2 trigonometric identities. Okay. So I'm going to stick you guys into groups, and just to sort of dissuade any worry about how complicated these look, they are hard, right? And this will involve a lot of staring at the wall or staring at your computer screen and trying to figure out what would work best. Okay? So I don't expect everyone to get this off the bat. Okay? This stuff will take practice. Okay? So I'm put you guys into break rooms. I have you guys think this out. Okay. You guys, thumbs up, thumbs down?
I couldn't, so I just divided into sine 2x and then sine squared 2x, and I was able to change the last one, but I don't know how they got that 1/2 in front and how they got rid of the 2 in the denominator.
Mm-hmm. So it's all multiplied.
Multiply it by 2?
So no. So a division by 2, right,
Mm-hmm.
is also the multiplication of a half.
So you just multiply everything by 1/2.
Exactly. Cool.
Yes.
You'll see what I'm talking about when I write it up.
Okay.
Yeah. Let me go see the other groups. Let me see. Oh, Madison's here. There. Okay, I'll be back. You guys, thumbs up, thumbs down?
I think I'm getting it.
So what'd you do?
I'm still doing it. I just figured out that I was supposed to make them equal together.
Yeah. It was really hard to get up this morning. I'm so tired.
Yeah, I feel you.
Oh, shoot.
I didn't want to be late, so I was like, I'll actually turn on an alarm today. Because, like, the stuff that we're learning right now is like, I just have a headache.
I know.
Trying to learn it, so. I was like, okay, I'm going to actually be on time and pay attention. So,
yeah.
So I'm working on the left one.
Yeah.
So since it's cosine of cosine cubed.
Yeah.
I took out 2. I splitted like 2 of them.
So you split it. Yeah. So you split a square and a cubed.
Yeah.
Yeah.
So it's just a singular one and a square.
Yep. That's enough to do it, actually.
Yeah, and then I expanded the square.
Mm-hmm.
And then put on the same denominator.
Yep.
by making the other one like over 2 or whatever,
Mhm.
and then so it's 4, and then the only problem I have is that for the 2 cosine 2x, are you supposed to make you're supposed to do that so it's makes it into 1/2?
It's all based off of the formula.
I'm facing the formula. What makes one? Oh, okay. I think I get it.
So there's the
I get it. I get it now. I get it now.
Yeah. Okay.
Yeah, yeah, yeah. Since it's in the parentheses, it actually doesn't go into the other one. So like,
I think I see what you're talking about. Yeah.
yeah. So
Yeah.
both the signs or things go in. It's really hard to say this and try
I
to
know.
articulate it
And
real hard.
yeah. Okay. Let me go visit one more group, and then I think I might call you guys back in.
Okay.
Okay. Whoa. Did I accidentally finish the break rooms by accident?
Yeah.
Oh, no, I didn't. Let me grab this group. This dude. Yeah. I'll close all the windows. I'll close all of them. Oh, man. All right. Okay, so for these that require proofs, um, I wanted to show you guys this because it literally happens to everybody. And when we get to the proof section, so this where we have tons of things that we need to prove, and we don't know what step to take. So we sit there and we're like, I don't know. This is the scene I wanted to show you guys. Yeah, mood. Oh man. Yeah. No joke, when you start getting the proofs like these that we're doing, it'll sometimes feel like that. You don't know which one to go and do, which one to try to hit it with. So you sit there and you stare at the board forever. until you think of something. Yeah, it's not good at Corona time. So, let me go ahead and do these two. For the most part, I think everybody got the first steps, but then the things that were worrying people was the rest of the stuff. Okay, like how did specifically the one comment that I got from everybody is, how the heck did that 1/2 show up? And it turns out it sort of pops out of everything that you were doing before. So for this, I'm going to start with this side. I'm going to start with this left-hand side. I'm going to turn it into the right-hand side. So sine cubed of 2x, right? I can go ahead and split that up into sine of 2x times sine squared 2x. Now, in doing that, notice that we were supposed to get a sine squared. It showed up, right? So the rest of the stuff should be coming from this thing over here. Okay, and that's where we use our reduction formula. So we have the sine one, which is 1 minus, right? So this is now equal to, I'm going to keep that sine x out front, times 1 minus cosine of 4x over 2. Okay, notice that this is this thing just straight up from our equation that we have up here. This one. Okay, now, some of you guys were wondering where the hell did that 1/2 come from? So it turns out this, I'm going to do sine of x. I'm going to do this. Whoops. 1/2 times 1 minus cosine of 4x. Right? And then there was a multiplication there, right? So if we go back to 2 times 3 times 5, right? That is 30. That's the same as 3 times 2 times 5, which is also 30. So the idea here is we can permute, I have something in the chat box. How do you find the 1/2? Yeah. So we can permute the three numbers in any which way and we still get the same 30, right? So that's exactly how that 1/2 gets popped out of there. So notice all of these are multiplications, right? So I'm going to just pop out the 1/2. So 1/2 sine of x times 1 minus cosine of 4x. And there you are. We are done at that point because we have the right-hand side now. Okay? Okay. The next one from the quick checks, you do it in a similar manner. I'm going to go ahead and skip it so we can move along. Half angle formulas. Like I said, today was going to be just me throwing equations at you.
Quick question.
Right. Yep.
When is the test for this these chapters?
This coming Wednesday.
Okay.
Cool.
And what chapters is it on?
It is, I think it's going to be 6 and 7.
Okay, perfect.
Cool. Okay. Half angle formulas, same thing. Just gonna throw a bunch of equations at you, show you how to use them. That's it. Okay. Oh, sorry, 6 and 7. Did I say 5 and 6? 6 and 7. The exam will cover chapters 6 and 7. So that means 8 will be left for the final. Okay. Again, these are what are called half-angle equations. We've already solved a couple of these, but we use different methods, right? But now we can use a couple more, okay? And I think after that, lecture questions, yay. So in this case, we can use halves of angles to find other angles, okay? So for the example, I give you guys sine of 15 degrees, right? Notice that sine of 15, right? That is equivalent to sine of 30 divided by 2. Right? Prime example of that one right there, right? So then I can now do plus or minus the square root of 1 plus cosine of 30 degrees over 2. And we know what cosine of 30 degrees is. That is, oh, I know what's at. In the chat box. Did I use the wrong? Yeah, it is minus. It is minus. Minus. That was my bad. Cosine of 30 degrees, we go to a unit circle. It'll be 1/2. Oh, sorry, root 3 over 2. Plus or minus the square root. And since we can't make this any nicer, we are done.
How'd you get that as your answer?
We're using this formula up here, this one right here.
And what? So I noticed that it says find sine 15 using the half angle formula, and we have 15. Is there a reason why we did sine 30 over 2 equals plus or minus square root 1 minus cosine 30 over 2?
So we needed to manipulate that 15 so it'd be a half of another angle. So notice how this thing works out, right?
Yeah.
Some angle divided by 2 turns it into that full angle.
Okay, so you multiply it by 2 to get 30.
Exactly.
Okay, which is why you got 1 minus cosine 30 over 2 now. That makes sense now. And then you got the you found 30 the degree, and then you got square root 3 over 2.
Right.
Perfect.
So
Okay,
then
perfect.
this, the 30, that's going to be my alpha, right?
Awesome.
Alpha.
Perfect.
Yep.
That one was pretty quick.
That was pretty quick, yeah. So we did a sine of 15 degrees before in a previous class from a previous section. This answer is the same as the ones that we got back then too.
Okay, perfect.
Yeah.
It seems like there's like a lot of puzzle problems in these chapters.
Yes. That's why I showed you guys that one scene from Big Bang Theory. It feels like that every time you do these. You stare at the board, you stare at your paper for like ever. You're like, I don't know what to hit this with.
So I feel like, do you think it's a lot of switching around, like just changing things out and then just seeing what you get until you get like the right side? Because all you're doing is
Yep.
matching the right side up, right?
Well, like I said, from 7-1, you can. There's multiple ways to solve these.
Yeah.
Well, not in particular these, but for example, these the proofs, right?
Yeah.
There's multiple ways of solving these. You turn either the left-hand side into the right-hand side, the right-hand side into the left-hand side, get both sides down to a common point, right? Or
Yeah.
turn them into already known identities,
Okay, so
right?
there's some different methods, basically.
There's different but those are like global methods, right?
Yeah.
The way in which you hit it with your trig identities from your trifold, from
Yeah.
the notes or whatever, that can vary wildly between all of you guys.
I
Does that
got
make
you.
sense?
Yeah.
And the final goal is to do one of the four things I just said, right?
Yeah.
Left hand side into right, right to left, to a common point, or to a already known trig identity. So all of your guys' processes will be vastly different, but the goals for all of them will always be the same. You're going to be doing one of those four.
Okay, I got you. I got you.
Yeah. Okay.
Yeah.
Okay. Besides that one, I'm done. I want you guys to try out the lecture questions. Yeah, try out the lecture questions. How many is it? Ooh, those are fun. Okay, so I'm going to give you guys maybe half an hour. So we'll be back in here at about 11. And I'll do 7-4 really quick.
I'm assuming that we're gonna be doing 7.4 today, and then take the test on Wednesday, and then on Monday are we doing chapter 8, and then we're taking the final on Wednesday, next Wednesday?
Yep.
Is it next Wednesday?
So yeah, today we're going to finish up as much of 4 or 7, chapter 7 as possible. I think we can get through chapters all the way through 7-5.
Yeah, I think we can too.
So then all of chapter 7 will be on exam 3. 8-1, 8-2 we'll do on Monday. I have a feeling Monday is going to be a very short day. It seems like, I'm pretty sure for some of you guys it'll feel like chapter 8 is going to be really complicated. It's not. I'm pretty sure we're going to be done really quickly on Monday, maybe an hour before class is done. And Wednesday, following Wednesday is final, and that's it. Which means I'm going to try to get you guys a practice final sometime this week. Okay, like I said, lecture questions, try them out. in the chat box. Yeah. I thought they were up. Full list. So, 7th is the last one. Four, six. Oh no. Okay. Mohammed. So 5-4 and so April 29th and May 4th. Those are growing up. May 6th, it never actually finished converting. So I'm gonna let it do its thing. Once it does convert, if it converts before the end of class, I'll upload it. Okay. But the 4th and the 29th, they're going up right now. And besides that, how are people doing with the stuff, with the lecture questions? Some of them are easier than others. Oh, I gave you guys way too much space for number 4. Oh, that's elegant. Okay. Everybody's doing okay? Just making sure. I'm still here. If you guys want to answer questions, I have headphones in, so even if I step away, which I'll do periodically here and there. Still showing deleted videos, huh? Okay, let me see something. Okay. I'll check it really quick before we move on. I think you can, well, that's what I'm doing right now. I'm recording directly. But I can't record directly to YouTube. At least I don't think so. It won't let me do all the crazy things that Zoom lets me do. No, I don't think so. Let me see. Okay. I can try. Let me see.
I have a question.
Yeah.
When it says, I just came back. When it says the first three double angle formulas, does it
Yep.
mean like for the cosine one, do I just use the first one?
Right. So
So
these
I
two,
use
or
yeah.
these three.
Oh, okay. Use those three angles.
Well, prove these three equations, right? Using the stuff from 7.2. So using these. Let me scroll. Yeah, using these right here.
Mm.
So using those 6, right?
Mm-hmm.
Try to prove those 3. You don't need them all.
I can choose any three.
No, well, I'm asking you to prove all 3, but you won't need all 6 of these from the
Steps.
chapter before. Yep.
Okay. Okay, then I got another question. What's the other one in the cosine formula?
What do you mean?
So you know how it says cosine of square theta minus sine square
Is
theta?
it the lecture question?
It's more of the formula itself.
For which one? For the ones that I was just showing
Double
you, this
angle
one?
form. Yeah.
Yeah.
Why is there like 3 different ones for cosine?
They're all manipulations of
The first one, or
no, not the first one.
cosine?
That they're all different versions of the same thing, and it's just different manipulations of them. That's it. So, for example, like number 1. So this one, right?
Mm-hmm.
You get directly from the equations from 7.2. Okay.
Mm-hmm.
Okay. If you grab cosine squared theta, right, and you hit it with the Pythagorean theorem identity one, so the sine squared plus cosine squared is equal to 1,
Mm-hmm.
right? You get this one, right? And then same thing with this one. If you grab the sine squared one and turn it into cosine squared, you get the next one down. So that's what I'm saying. It's the same one with different representations for each one.
Mm.
But the one that you should be able to get really, really quick is that very first one.
Then we have to prove the
And then
manipulations.
no, just
Okay.
that first one.
Okay. That's what I was like harping on the most. Okay.
Yeah, no. Okay, I'll be back.
Okay.
All right, maybe about another 5 more minutes, and then we'll try out a 7-4. All right. All right, all right, all right. I am so tired. So tired.
Let's call it a day.
No, I can't do that. Oh, oh, that's funny. Did I? Okay. It's not too bad. All right. All right. Throwing some more formulas out at you. Like I said before, we're just going through, you know, that trifold that I gave you guys with all the formulas on it. We're going through that and just adding equations left and right. Okay. And just sort of learning how to use them, really, not any more than that. Sum to product and product to sums. Sometimes you get products, you can change them into sums, and sometimes you get sums and make them into products. The first direction we're going to do is product to sums. So you have the multiplication of two trig functions, and they turn into additions and subtractions. The formulas are right here. Turns out you can get all of these back from those very first couple of equations. Which ones are they? The sum identities ones. So remember the sine of alpha plus a beta is, it was a whole bunch of mixy ones. Yeah, those. Okay. These work out exactly as they're supposed to, right? This is literally just like plug and chug almost. Find the right equation that fits it and then use it. Okay. So first example, write cosine 3x and cosine 3 theta and cosine 5 theta as a sum or a difference. So that's the multiplication of two cosines. Multiplication, oh, wrong one. Multiplication of two cosines. Multiplication of two cosines. Okay. So that makes, let's say that one my alpha and that one my beta, right? This is going to be 1/2 cosine of 3 theta minus 5 theta plus cosine of 3 theta plus 5 theta. And that one came from this one. So equal 1/2 cosine 30 minus 50, that's going to be, 3 theta minus 5 theta is negative 2 theta, plus 3 theta plus 5 theta, that's going to be cosine of 8 theta. And we're done. Notice how easy that was. Okay. Quick checks. I want you guys to try these out really quick. Yeah. Some of these values actually exist on the unit circle, so I want you guys to try them out. Try to find these values out, okay? So I'm going to send you out to breakout groups one more time, give you guys maybe 5 minutes to try them out. Cool. Oh, I need to exchange some of you guys. Let me see, put you in there. All right, let's try this out. All right. Thumbs up, thumbs down.
I think thumbs up, just plug and solve, right?
Right.
And I have a question. Should we simplify for final
For
answer?
for now, just to get used to the equation itself, like that we're working with, you don't have to.
Okay.
Simplification will come later whenever you need to actually do it to make it simpler. But for now, I'm just concentrating more on how to use the equations. Okay, I'm gonna go bug another group. Thumbs up, thumbs down, thumbs middle.
Yay.
Yay, okay. I'm gonna bug one more group. Wait, I already bugged you guys. Thumbs up, thumbs down, working out.
It's I get it for now.
For now, okay.
For now, until you introduce something more difficult.
No.
I'm waiting.
Okay, let me call people back.
Okay.
How'd that feel for people? I don't know if people know how to do the thumbs up or thumbs down. Okay. Like I said, this chapter is going to fly by really fast. It's me showing you guys how to use more and more equations. Okay, fine. Let's see. Let me share the screen really quick. Okay. I'm just going to try the very first one, cosine, cosine. Actually, no. I'm going to do sine, cosine. So the second one. So that's going to be a sine, cosine. That'd be this one. Depending on which one you need, that's the one you use. That's simple. So it's going to be equal to, there's the 1/2 sine alpha plus beta. So I'm going to start calling stuff. Actually, let me call stuff first. So this is going to be my alpha and this is going to be my beta. Equal to 1/2 times sine of 195 plus 15. And the rest of the equation tells you plus 195 minus 15, right? In this case, you can simplify a little bit more. 1/2 195 plus 15, that is 210. Plus 195 minus 15, that's 180. Right? These are actual values that are on the unit circle. So I can actually find these. Sine of 210. So for 210, the sine of it is, where is it? There it is, negative 1/2. Plus sine of 180, which is 0. All right. Negative 1/4. That's it. We're done. Okay. So the first bunch, right? These are product to sum. So we had a product of things and we turned it into addition of things, right? This is the backwards, right? Sum the products. We have additions of stuff and we turn them into multiplications of stuff. Okay? So in this case, for this next one, sine of 4 theta minus sine of 2 theta. That looks like that one. Depending on which one you need, that's the one that you use, right? So, using our equations. Equal to 2. So I'm going to start calling stuff here. That's my alpha. That's my beta. So sine, right? 4 theta minus 2 theta over 2 cosine of 4 theta plus 2 theta divided by 2. That's it. Right? We'll clean it up a little more. 2 sine of 4 theta minus 2 theta, that's 2 theta divided by 2, sine theta. And then cosine of 4 theta plus 2 theta, that's 6 theta divided by 2, that's 3 theta. Cosine of 3 theta. We're done. Don't need to clean it up any more past that. Whoa. Oh, it's on to shape. Haha. I don't need to do anything more than that. Okay. Okay. One typo, there was supposed to be a negative in between here. So it's going to be cosine alpha minus cosine beta. So that sort of gives it away for you guys. Okay. Okay, again, break rooms. Try these out. Are you gonna get your dad one of those machines or no?
Huh?
Are you gonna get your dad one of those machines that you bought?
Yeah, he said he would need it.
Yeah. That one that you got was pretty good.
Yeah, he said darle a poner
Mm. And it helps it.
in the morning, and when he gets up, he tries to stretch.
Yeah. Will help him out.
That's all. I'll send it to Barbara.
Yeah.
Delivered there.
Fine. You guys good? Boom. Okay. Simple enough, right? For now. Okay. I'm gonna go mess with another group. Thumbs up, thumbs down. Dana? Let me mess with one more group. Simple enough. Thumbs up, thumbs down.
I think thumbs up.
All right.
Yep.
Simple enough, right? It's not a. It's a lot easier than the stuff that we've been doing before.
Yeah.
Yeah. Okay. Let me call people back. So today is super boring compared to other days. If you guys haven't noticed yet. I'm just throwing equation after equation at you guys, and you just have to find the right one and make it fit. All right. Share the screen one more time. Boom. Okay. So this is the cosine minus cosine. That's this one. So I need this one. Equal to. So you guys can stop me if you need to, okay? Right there. Okay, minus 2. I'm going to start calling stuff like I usually do. This is my alpha. This is my beta. So sine alpha plus beta. So 11 pi over 12 plus pi over 12 divided by 2 times sine 11 11 pi over 12 minus pi over 12 divided by 2. We'll clean this up a little bit. Minus 2 sine 11 pi plus one more pi, that's 12 pi, right? So 12 pi over 12 on top divided by 2. Let me actually make a big parenthesis, right? Times 11 minus 1 is 10, right? So it's going to be sine of 10 pi over 12 only divided by 2 minus 2 sine of, this is going to be pi over 2, right? Times sine, that's going to be if you divide it all by 2, that's going to be 5 pi over 6, all on top, divided by 2. So now, just up here, this is where we have to do that little 5 pi over 6. So it's divided by 2, so it's multiplied by 1/2, right? So we get equal to minus 2 sine of pi over 2 times sine of 5 pi over 12. Okay. 5 pi over 12 doesn't exist anywhere on our unit circle, so we're going to just go ahead and leave it at that. But the idea is that's how you use it. Got it? Okay. I'm going to skip the last quick check, though I do want to do this one for the example. And then we'll move on to lecture questions after that, okay? It's exactly how you think this would be. Okay, so I need the cosine, well, it's cosine minus cosine over the sine plus sine. I go back up to my thingies, right? Oh, hold on. So cosine minus cosine, that one over cosine, or sine plus sine, that one. So the cosine one. So I'm going to turn the left-hand side into the right-hand side, okay? So that's going to be, whoops, minus 2 sine of 4t plus 2t over 2. And that's going to be times sine of, the hell am I looking at here? There we go. 4t minus 2t over 2, all divided by the sine plus sine one. That's going to be 2 sine of 4t plus 2t over 2 over cosine of 4t minus 2t over 2. Okay, I'm gonna automatically start cleaning stuff up. There's a 2 on the bottom and the 2 on top. If you guys notice, both of these are equal things, so those go away. So now I get left with this, right? You get left with negative sine of 4t minus 2t over 2 over cosine of 4t minus 2t over 2, right? So now we get to mess with that inside bit, this thing, all of that. And it's going to be, so 4t minus 2t, that's 2t, divided by 2, I get left with t, minus sine of t over cosine of t. Sine of t divided by cosine of t, that is tangent. Back from chapter 5. So we're done. Notice how nice that looks. Okay, so like I said, I want to skip the quick check. I want you guys to just go straight into the lecture questions. And I want you guys to try them out. Okay? I think it's only one page worth, yeah. So within those, I'm going to give you guys 15 minutes, 20 minutes. I'm going to give you guys 20 minutes to try these out, okay? So I'm going to still be around. Ask me questions, okay?